Installing another caching plugin won't fix a slow time to first byte. That delay happens before plugins even load. Instead, we are going to run a simple 3-step diagnostic test that pinpoints exactly whether your network, your server, or your caching setup is causing the delay. To prepare for the test, open up a new incognito or private browsing window and have your WordPress website URL ready to copy. Isolating the exact layer of your bottleneck prevents you from wasting hours configuring optimization plugins that mathematically cannot fix a server-side problem. Look at this timeline. Time to first byte is a 3-part journey owned by different technologies. First, the network handles DNS. Next, your host boots PHP. Finally, delivery decides if your page is cached or requires a database run. Let's test your PHP execution. Open Chrome Developer Tools, navigate to the Network tab, and load your website URL. On this waterfall chart, click the first file at the top. Locate Waiting for Server Response and write this initial number down. Now refresh the page to trigger a cached response. Check the waiting metric again and write down this second number. This chart compares the two numbers you just pulled. You are looking for a massive gap, like a 1400 millisecond uncached hit dropping to a 16 millisecond cached hit. If the uncached number is high, but the cached number drops to near zero, your caching plugin is working perfectly. But the server's raw PHP execution is failing to meet the 200 millisecond threshold for a fast site. We must account for content delivery networks like Cloudflare. They cache files at the network edge, artificially lowering the first number you see. If you use a CDN, temporarily pause it. Alternatively, use an external testing tool to ping your server's origin IP address directly. Now compare this direct origin reading against the initial edge reading you recorded in step 1. If the edge is fast but the origin is slow, your CDN is masking a server problem. Dynamic requests that bypass the edge, like WooCommerce carts or logged-in users, will still suffer from that slow origin speed. Step 3 tests your capacity. Quickly refresh your web page multiple times in a row, watching that time to first byte metric on each reload. Observe the pattern on this graph. We want to see if your numbers stay relatively flat and stable, or if they swing wildly into the red under rapid requests. Servers process code using PHP workers. Think of these as open lanes available to handle visitors. If your numbers spike, those lanes are likely full, or a noisy neighbor on your share plan is hogging the hardware resources you need. This matrix maps results to solutions. High uncached times need a faster PHP handler, like LSAPI, or server-level caching, like Lightspeed. If dynamic pages are the bottleneck, you need Redis object caching for memory storage. If numbers swung wildly, secure a VPS for isolated resources. Lightspeed, Redis, and isolated resources are architectural server properties. This proves why WordPress plugins can never fix underlying hardware limitations. You've completed the diagnostic. You now possess hard, undeniable data isolating exactly where your site is lagging. Instead of blindly installing plugins, you know the exact technical requirements, like Redis or LSAPI, to demand from your hosting provider. Check the description below to download our 7-point hosting checklist based on AHosting's benchmarks. You can use it to compare your current host's stack against an optimized one. Measuring the data first is the only way to make the right infrastructure decisions and achieve a truly fast WordPress site.